So welcome to lesson 1 in unit 1. So this is the video that I've recorded ahead of time so that you can take your time and watch it. I can't promise that I'm going to be able to do it for every single video, but I'm going to try just because you're going to be getting used to the notes and using whatever software you're using. I just want you to be able to pause and take your time and do the things that you would need. So this is lesson 1. It's kind of similar and tied into the lessons that the activities that we were doing. So we're talking about units, okay? So it's very important that when we're in physics, we're talking about unit and how to do unit conversion. I am using a highlighter here. Everything that I highlight, I would suggest when you're taking note, you also choose to highlight it. So I know it's going to be hard if you're not printing your note out, but then not using, I do want you to try to use Kami and see if you can follow along. Okay, so the first thing I need you to remember are these things called the base unit. We do use this thing called the SI unit. Basically, it's a standardized unit that all science community would use. And I think a lot of these you would already know. Yesterday, when you watched the video, you probably have already seen them. So I do need you to know and memorize the 7 things. You will be getting a quiz or a test. You do need to know all of that. Okay, I know you were copying it down, but you do know that there are some basic length and stuff that we would be doing measurements on. So length is measured in meters. The symbol is lowercase m. Mass is measured in kilogram. This is the one that people always forget. They always think like, oh, it's in grams, it's in kilogram. Okay, time is measured in seconds. These are called the base unit. And electric current are measured in amperes. You've done that in grade 9. Voltage is current times resistance. So current is basically how quickly the electrons are flowing through a wire. If it's getting really fast, it will get hot. Later on when we talk to unit 5, if the current is too high within the house, sometimes when we have too many things plugged in the house, if the current gets too high, it can burn down the house, right? That's why you have circuit breakers and stuff at home or a fuse to eliminate that. Temperature, we are so used to using degrees Celsius. In, say, United States, sometimes they use Fahrenheit. But in terms of science, the actual temperature that we use the unit called Kelvin, a capital K. Some of you, if you're taking grade 12 chemistry, you probably would be working on it with the unit. If you took like grade 11 chemistry, you probably would have done this too when they talk about the gas law. Quantities of substance is also another chemistry quantities that was talking a lot. So how much stuff is there? We use moles. And last one is intensity, how bright something is. The unit is called the candela. One way to remember is, you know how back in the days when people say brightness and stuff like that, you're talking about like using candle. So candela is kind of like that's where the word was derived from. So you will need to memorize this. Okay, so I'm just going to use a pen and I'm going to put a big star. Can you try to write it into your note too? So pick the drawing tools and I want you to write memorize. Okay, so have this chart memorized. So honestly, pause the video, have a sheet of paper, write out the chart without looking. That's the best way to know if you're able to memorize. You don't have to know them in order, but you need to be able to list out the 7 measurements and the 7 symbols for it. Either column is fine, okay? Okay, so those are the units that are the base units. So if I actually go to this picture right here, these are the 7 base unit that we're talking about. So on a test or a quiz, I can ask you, is meters per second a based or a derived unit? Okay, the easiest thing you can do is just take a look at this column, the 7 things that we're talking about. If it doesn't belong to any one of these 7, it is considered to be derived. Okay, so that means meters per second, if this is the measurement that I'm asking, it would be a derived unit because it doesn't belong to the 7. So basically, the rest of the page that are on the right-hand side, so any of this page, any of the pages that are on the right-hand side, they're all derived unit. Okay, and derived units sometimes happen. You would have done things like that before. When I talk about area, it's length times width, right? When I have something that is a length multiplied by something that is a width, the unit becomes meters squared. If I have a volume, it's length times width times height, right? So then it becomes meters times meters times meters. They becomes the meters cubed. Speed, on the other hand, I use a distance divided by the time. It might not necessarily be meters per second. They could be in other derived unit too. But all I need you to know is that as long as they don't belong to the 7. What are my 7 again? Pause it. Say it out. Can you say all the 7? All right. So all these are considered to be derived. Okay. So memorize the 7. And going back to this now, it's called a metric conversion. Okay. So unit conversion. And I'm going to add this note in. I want you to actually write it into. So this is called metric conversion. Okay, so metric conversions are converting between some commonly used unit. I think some really commonly known one for you is like, say, 1 meters, it equals to 100 centimeters. And another very commonly used one is 1 kilometers, it equals to 1,000 meters. So things like that, right? Because sometimes the value can be really big or really small depending on what unit you use. Okay, and so you need to recognize the staircase. Okay, we call this the staircase. The kilo, hecto, deca, base, deci, centi, milli. Those are called the staircase. So I'm going to highlight that. There's 7 steps in total. So kilo, lowercase k, hecto, deca, base. Base doesn't have a prefix. We call these the prefix. So I'm going to put it at the front here. So it's like right here. So I'm just going to add it to the, so this column is called the prefix. Okay, and with the prefix, anything underneath it will become a measurement. So you actually have to put in whatever the unit is. Say, for example, if I say I am now measuring length. Length is measured in meters. What I can do is I can actually fit it in and say I can have decimeters, centimeters, millimeters, decameters, hectometer, and kilometer. Right? Those are commonly used ones. I can also say, hey, I don't want to measure length. Let me measure mass. Okay, so I'm just going to change the color. If I'm measuring mass, I'm going to use G for grams. And does that mean I'm now going to put the decigrams, centigrams, milligram? That's a commonly used one. We don't use decagram a whole lot. We don't use hectogram a whole lot, but we definitely use the kilogram a whole lot, right? So that's basically telling you that it's like every time I move one step, I have to move my decimal places. Okay, so let's go through how to do that. Okay, for example, I have 3.2 kilometer equals to how many meters? What you need to do is you need to figure out the starting point to the ending point. Okay, where am I starting and where am I going? Okay, so I'm going to write some simple rules on the side. Okay, I need you to write this out too. I know some of you really get this, but then sometimes some of you might not be as strong in math and you want some review. So I'm going to go into a bit of a detail, a step by step, what we're going to be doing. Okay, the first step I want you to do is I'm actually going to color code these steps and then I'm going to show it to you with the example so it's easier to follow. You, if you're using Kami, you can choose to color code your stuff fairly easily too. Okay, so I'm going to click step 1. Step 1, I want you to circle your base unit. So step 1 with example 1, I'm going to rewrite out example 1 so I have a bit more space. So question 1 is I am going from 3.2 kilometer and I want to convert it into whatever meter. Okay, the first thing I'm going to do is I'm going to circle my base. What is my base? My base in this question is the meters. Remember just now we said that whatever that was in the middle, that's the base, right? Like the one that is the middle one is called the base, right? So if I go back to here, my base has nothing. And so I went from meters. See how meters is my base. Now step 2. I'm going to turn green. I'm going to ask you to underline your prefix. Okay, so I got kilometer and nothing in the prefix. Okay, nothing in the prefix means this step. Okay, so The third thing that I need you to do is I need you to figure out the steps and know where to move it. Okay, so I'm going to go purple. Number 3. No, let's not use purple. Purple looks too close to the other color. Let's use red. Okay, step number 3. What I need you to do is I need you to count the number of steps either to the right or to the left. To the left or to the right. Okay, so let's figure this out. So I went from K to nothing. Okay, so what that means is I need to go from K to nothing, which is this step. Do you see how I have to go from kilo to the base? So you have to imagine this, okay? You have to imagine yourself starting. It's almost like you're stepping on a step. I'm gonna do a star here. I don't know how effective this is gonna be. I'm gonna put a star here. Okay, there's my star. Okay, you have to start from here. Okay, I am starting at the K. I'm standing on this step. You don't count this step because you're already standing on it. I need to count how many steps it takes for me to go from K to the base. So I'm going to start from K and I'm going to try to move this guy. 1, 2, and 3. Do you see how it takes me 3 steps to move over to the right hand side? So this step, so for this example, I have written that I have to go 3 steps to the right. And because knowing how many steps I have to move it, it leads me to step number 4 is now I know how many decimal place, how many spots do I have to move my decimal place. Okay, so step 4 is move the decimal according to step 3. Okay, so let's see. I was at 3.2. I'm just going to rewrite this guy out at the bottom so I have lots of room so you can see how I'm moving it. This, I'm going to change it now to back to the blue. Okay, this is the decimal place that I'm moving. I need to follow this step that is 3 steps to the right. So you always put the decimal place after a number. So I move it 1 step, 2 step, and 3 step. My new decimal place is there. When there are these blanks, what you have to do is you have to fill in the zeros. Okay, so meaning my answer is now 3,200. Do you see that? Okay, so my final answer is 3,200. I know that this seems like a really long steps, okay? But I need you to try to get used to it. Then eventually, basically it's a 1-mark question. When I give you a quiz like this, I don't need you to write any of these guys out. Right? But I do need you to tell me the number, and it has to be the correct number of zeros or you're not going to get it right. Okay, so let's try the next one. Okay? So I'm not going to go through all of this different like color and stuff like that. I'll try. Okay? Circle the base. First step. My base in question number 2 is my grams. Step number 2. Underline the prefix. Prefix is the letter in front of it, so I'm going from C to K. I'm just going to erase these guys. I'm going to start over. I need to use my staircase again. Okay, so let's see where I'm starting. I am starting from C, so I'm going to move this star to C. This is my starting point. Okay, you can use your pencil, use your hand to point to it. I am going from C all the way to K, right? So I need to stand on the C, and I need to count how many steps do I need to move so that I will get to K. Okay, so C to K. So I need to get here. This is my ending point. 1, 2, 3, 4, 5. I have to move it 5 steps to the left. So 5 steps to the left. I'm writing my little rough note here. Okay, and how to move it is I need to move my decimal place. 9,800. I don't have a decimal place. But I don't know if you remember, when they don't put a decimal place, your decimal place is actually right at the end of the integer, right at the end of the number. I don't need to write it because there's nothing else after it. Okay, so 9,800. I'm going to just rewrite it at the bottom here so it's bigger. So 9,800, my decimal place is right at the end. I am now going to have to follow and count 5 steps to the left. Okay, 1, oops. Okay, I just totally changed my pen, which is very cool, but I'm just going to redo it. Okay, start from here. 1, 2. Do you see how I jump a number? Sometimes people put it in the middle of the number. Don't do that, right? I always put it behind a number. 1, 2, 3, 4, 5. My dot is here. That means I have to fill in a 0. And I'm going to write my answer here. 0.09800. You almost don't need to write it because my decimal place is at the front. Proper math, whenever the number is smaller than 1, you stick a 0 in front of it. Okay, so I won't even write this in. So 0.098. If you put it on your quiz and you say 0.09800, I would mark it right. But this is the cleanest way to write a proper number. Okay. All right, last one, number 3. I'm going to erase some of these things. You can rewind it if you need to see it. I'm just going to erase some of these guys, just so I have a bit more room. Okay, so 4.7 liters to milliliters. First step, circle my base. My base is L and L. Underline my prefix, the number, that letter that is in front of the base. I have nothing, and the M. Nothing means I'm starting at the base. I have to go to milli, okay, base to milli. So I'm going to take my star. I start on the base. You don't count that step. I have to move how many steps to go to the M. Is it towards the left-hand side or the right-hand side? So I have to go 1, 2, 3 steps to the right. So 3 steps to the right. So that means the 4.7, according to step 4, I have to take this decimal place and I'm going to move it 3 steps to the right. New decimal places here. Put in my placeholder, 4,700 milliliters. All right. So now, more than just converting between, the left and right, we're now moving with things that we see all the time. How many minutes in how many seconds? 8 minutes. Can you do it on your own? If I have 8 minutes, how many seconds in there? So hopefully you know that every minute it's 60 seconds. So that means I have to go 8 times 60. Bring your calculator out. Whenever I do example, I want you to try it on your own. Especially with video like that, you can slow down, pause it or whatever and get an answer. So 8 times 60, so I should have 480 seconds. All right, more tricky. 4.5 hours equals how many seconds? Pause the video if you want. Figure this out first, then check the answers with what I give you. Okay, 4.5 hours. I know that each hour has 60 minutes and each minute has 60 seconds, so I have to multiply them. So 4.5 times 60 times 60. So the answer is 16200. If you are good with numbers, every 3 numbers you leave a little blank. It just makes marking a bit easier for me, but if you couldn't, that's okay. All right, days into hour. I have 22 days. How many hours are there in each day? There are 24 hours in each day. So I multiply them together. So 22 times 24, 528 hours. Good so far? All right. The last one are things that we use in physics all the time. And I would like you to write this down. Make sure you write it down. On the day of tests and quizzes, some of these things will be given to you. Some I need you to memorize. I'll clearly tell you what it is, right? But I need you to have access to this because sometimes when you do your test, I won't remind you of things like that. All right, so I'm going to ask you to do kilometers to meters. So I need you to draw this out, okay? Write it on the side, somewhere at the top of your page that you will remember, okay? Whenever I go kilometers per hour and I try to convert something into meters per second, what you do is you would take whatever the value and you would divide it by 3.6. Okay, opposite to that. So if I flip it, I don't know if you would get it. How about if I say if I want to convert meters per second into kilometers per hour, instead of dividing it by 3.6, what is the opposite of dividing? It's multiplying. Okay. All right, so I already gave you a little space here. So this is important. So put a big box around this. I like to draw it like that. Okay, you can highlight it. And also this. So let's do the example now. Okay, so they give you 100 kilometers per hour into meters per second. So I'm using this guy, right? I'm trying to convert kilometers per hour into meters per second. I would take whatever the value and I would divide it by 3.6. Okay, so that means I would take, you don't have to show the rough work, but I'm just going to write it at the top. I would suggest you write it down this time just because it's in your note. So I would take 100. I know that I have to divide it by 3.6. So take your number, use your calculator, 100 divided by 3.6. I get something like a 27.8. I'm just going to leave one decimal place for now. All right, so the next thing is they're asking you, how about if I go 16.7 meters per second into kilometers per hour? That means I'm using the bottom conversion. So that means I need to take whatever the value, the 16.7, this time I'm going to multiply it by 3.6. Okay, so I'm going to take the 16.7 and I'm going to multiply it by 3.6. So take your calculator, 16.7 times 3.6. So 60.12 kilometers per hour. Okay, so I am done the lesson. And you have a worksheet that is following at the bottom. So I need you to work on your worksheets. Okay, question 1, 2, and 3. Hopefully you did okay with the note-taking thing. Ask